Hey everyone, and welcome. Let's just jump right into this explainer. Today we're putting our focus on the Hyades. We're going to explore the absolute most accurate and, honestly, the most fascinating data we have on our closest stellar neighbors. We're unpacking years of astronomical research, deep sky surveys, and incredibly precise measurements to truly unveil the face of the bull.
So to start us off, I want you to picture something for a second. Have you ever actually looked up on a crisp, clear night and noticed that distinct V-shaped grouping of stars in the Taurus constellation? It is one of the most recognizable patterns in the entire northern hemisphere. And by anchoring our incredibly complex journey today in something you can literally step outside and see with your own naked eye, I'm hoping to show you that the cosmos isn't just abstract data. It's right there in our cosmic backyard.
Section 1. The Face of Taurus. The familiar stars in our cosmic backyard.
Now, when you look up at that V-shape, you are actually looking at a stellar family. And the secret to understanding them really comes down to one specific number, 153. Situated exactly 153 light-years from Earth, the Hyades is the absolute closest open stellar cluster to our Sun. If you map this out on a galactic scale using Gaia data, the core of the Hyades cluster pops out as this massive, bright orange overdensity. It glows so vibrantly precisely because it is so incredibly close to us. And that proximity makes it basically the ultimate laboratory for astronomers to study how stars form, live, and eventually drift apart. Oh, and by the way, while the really bright red star Aldebaran seems to be the eye of the bull in this cluster, it's actually just a foreground star. It's a cosmic photobomber. The true cluster members are stars like Prima Hyades and I Avene.
Section 2. Counting the stars. Moving from a few bright specks to hundreds of members. So when we transition to using really powerful telescopes, we realize this 650 million-year-old stellar family isn't just some random scattering of stars. It actually has a highly organized physical structure. The tightly bound core has a radius of about 3 parsecs, containing roughly 85 members. But then expand out to the tidal radius, which is about 9 to 10 parsecs, and we find 381 members. Go beyond that, into the halo extending out to 30 parsecs, and the total population jumps to over 700 candidate members. But here is the really fascinating part. The cluster perfectly segregates its stars by mass. The heavier, massive stars sink right toward that tight 3-parsec core, while the lighter stars and faint brown dwarfs get pushed way out into the broader tidal radius and halo. It's like an active, ongoing sorting mechanism.
Section 3. Mapping in 3D. Using Gaia data to build the ultimate cosmic map.
So how do we weed out those cosmic photobombers? Astrometrists combine the mind-blowing precision of the Gaia satellite with ground-based instruments, like the 2-meter robotic Liverpool telescope. By plotting stellar distance, which is known as parallax, against their brightness and their proper motion across the sky, distinct color-coded groupings emerge. The core, the tidal radius, and the halo are all confidently grouped together by these parameters. Because they were born from the exact same cloud of gas, they share a very distinct signature in how they move and how far away they are. Out of literally billions of background dots, this methodology perfectly plucks out our Hyades family.
Section 4. Rotation and Kinematics. A dynamic swirling community.
Up until now, we might have pictured the Hyades as just a static painting in the sky. But no way, it is very much a living entity. Because all the stars in the cluster are traveling together through space on parallel tracks, from our perspective down here on Earth, their paths appear to converge toward a single vanishing point. It's exactly like looking down a set of straight railroad tracks. Through this convergent point method, scientists have calculated that the entire Hyades cluster is hurtling through space together at a mean velocity of roughly 46 kilometers per second.
But here's the crazy part. They aren't just flying in a straight line. They're actually dancing. If you map the mean residual velocities of these stars, it reveals this really distinct, undulating sinusoidal wave. In astrophysics, seeing that wave is a telltale indication of 3D rotation. It proves that the cluster exhibits closed-loop motions. So the stars inside the Hyades are actively rotating and swirling around their shared center of mass as they travel through the galaxy. It's incredible.
Moving to Section 5, the binary star secret. Who actually lives in the Hyades?
To find out who the actual residents are, researchers conducted a massive 2.2-micron speckle imaging survey on the 5-meter Hale telescope. They were looking for faint companion stars that might be hiding right next to the bright ones. And out of the sample they observed, yes, they found 98 single stars, but they also found 59 binary systems and 10 triple star systems. A huge chunk of this cluster is intricately bound together by gravity. So when you look at a single point of light in Taurus, there's a very good chance you're actually looking at 2 or even 3 stars in a tight gravitational embrace.
And why does this matter? Well, this high level of multiplicity provides a perfect window into stellar evolution. See, in very young stellar nurseries, like T Tauri stars, the companion star fraction is quite high, sitting around 0.40. But in much older populations, like our own solar neighborhood, that fraction drops dramatically to 0.14. So where does the 650-million-year-old Hyades fit in? It has a companion fraction of 0.30. It represents a perfect evolutionary midpoint. It literally lets us watch how stellar multiplicity evolves and eventually declines over hundreds of millions of years.
Section 6. An evolving stellar family. The gradual dispersal into the Milky Way.
If we zoom all the way back out to look at the cluster's ultimate fate in full 3D space, we realize the Hyades isn't a perfect sphere at all. It actually has an elongated ellipsoidal shape. While it does have a centrally concentrated core, the gravitational pull of the Milky Way is totally taking its toll. The cluster has developed 2 massive tidal tails stretching out in both the x and y directions. It is slowly stretching out over an astonishing 80 parsecs, with stars in these tails just trailing off into the galactic void.
And that brings us to a really profound realization from the researchers who analyzed all this massive data. To quote them directly, "We observe our neighboring open cluster as an evolving object which is permanently losing bound members." Basically, the cluster is evaporating. The gravitational glue that held them together for 650 million years is failing, and the stars making up the face of the bowl are actively drifting apart, permanently dispersing into the Milky Way's halo.
So, I'm going to leave you with this final thought. Next time you step outside and look up at Taurus, what will you see? Are you going to see a static constellation drawn by ancient astronomers, or will you see a dynamic, rotating, and dispersing stellar family? A group of stars, exactly 153 light-years away, actively living out their shared evolutionary journey right before our eyes. I really hope this explainer has sparked your curiosity to look up tonight with a totally new perspective. Keep observing and keep wondering.